the first page, I'm just going to show you the key here. And notice what I did actually before. I didn't do this yesterday, but I went probability of drawing a black card, right? And then you didn't have to do this, but that's technically the proper notation, right? So if you would just want to fill in or check how you did there, we went all the way to 6 of spades, which is a very specific card. There's only one of them. You can use your, also for tomorrow's AC and moving forward, you're going to need the card, all the cards that hand out, you're going to need that. Or not. Some of you might just not use it. And so there's probability of drawing an 8, 9, or a 10 of hearts. Well, there is only one 8 of hearts, one 9 of hearts, one 10 of hearts. So I show how I add those three together. And if it's or, you just add up the possible outcomes out of 52. And then you have probability of 5. That just means any color, any suit, right? It's just a 5. There are 4 of them. If you look at your handout, there are 4 5s there. So that'd be 4 or 5 out of 52. A black 4, 5, 6, 7, or 8. There are 2 black 4s, 2 black 5s, and so forth. So I show how I do that. And it's 10 out of 52 without reducing. Okay? 10 out of 52, and then you get your decimal and your percentage. Spade face card. Spade is a specific suit. You're down to just one suit. And how many face cards does each suit have? 3, right? There are 4 suits, but spade in particular has 3. So it's 3 out of 52. Drawing a 6, 7, 8, 9, or 10, right? There are 4 of each. No color or suit specified. So it's 20 out of 52. And there's your decimal percentage. A red face card. If you think about that one. These are my red cards here. There are 6 red face cards. 12 in total, but only half of them are red. So that's where the 6 out of 52 comes from. And then you fill in the decimal. Go ahead. And then we have the back side, which you didn't fill in just yet. We're rolling 2 regular 6-sided dice, right? And we want the sums. Oh, I'm asking you, when rolling 2 6-sided dice, that should say, what do you think is the most common sum? I don't know, anybody play Settlers of Catan? Ever? Settlers of Catan? Anyways, that's where this would come in handy. But so 1 and 1 is 2, 3, 4, 5, 6, 7, right? You're just adding them up. And then keep going. 2 and 1 is 3, 2 and 2 is 4, 5, 6, 7, 8. 3 and 1 is 4. And then it's just, you fill in like this. 4 and 1 is 5, 4 and 2 is 6, 7, 8, 9, 10. 5 and 1 is 6. 5 and 2 is 7, 8, 9, 10, 11. 6 and 1 is 7. 6 and 2 is 8, and so forth. I think you get the picture. Okay. Which one is the most common sum? And you'll see a diagonal here. See that one right there? The most common is 7. That's with 2 6-sided dice, right? If you had 5-sided, 4-sided, 12-sided, that would all change, right? So keep that in mind. So making a table like this is very helpful. Maybe on, just don't put it on your study sheet. Don't. I'll make you do one of these on a test perhaps, but don't worry about having this. So we did the table, and then C, circle, highlight the sum that occurs most often. We've done that. What's the theoretical probability of rolling a sum of 9? So probability, sum of 9. There's 1, 2, 3, 4 possible outcomes out of total is 36 total outcomes, right? That's technically all the outcomes you could have is 36. So it's 4 or 36. And as a decimal, that'd be 1 over 9, right? So that's 0.111 or 11.11%. And I don't know if anybody wants to try this, but I used to, if I had you all in class, I'd make you actually roll dice and see if this actually ends up being the case, if your probability ends up being close to 11%. So you roll dice and you say, hey, you got a sum of 9, we didn't, right? So you keep track. After 60 trials or maybe 100, we should be close to this, right? So theoretical experimental should match if the sample size is big enough. Okay, so this will come back. Keep this chart. Some of the questions in our book refers back to this, so you don't have to do one of these again, right? That'd be a lot of work. Okay. Now, let's go back to our books. Back to our books. We're going to go to page. Sorry, I'm going to pause this because this is kind of warm up to what we're doing here. So page 158 in your books, okay? All right, Alfred rolled a die twice. Rolled twice, right? The first time it landed on a 5. First time. What's the probability that the second roll will land on a 5? So they're trying to make you believe, they're trying to trick you and saying, hey, because he landed a 5 the first time, right, there's a higher chance of it happening the second time. And that's not true. Probability of landing a 5 the second time is still 1 out of 6. Probability of 5 is 1 out of 6. No matter how many times you roll, the first event does not affect the second event. You could roll it a third time. It wouldn't matter. It's still 1 in 6. We're on page 158. A family consists of 3 children. The first 2 are boys. What's the probability that a third child will be a boy? Probability of the third would still be 1 and 2. It's still 50-50, even though, right, some families have more boys than girls, right? It's still 50-50. 49-51. Is it? Maybe there's something happening. Yeah. Maybe that one should be updated then. Okay. Yuna used a spinner below and landed on a heart. She spins it again. What is the probability that will land on heart? Still the same. So how many hearts? 1, 2. Probability of heart is 2 out of 10. Every time. Now, what if she spun and the first time she gets a heart and then the game says, okay, we're gonna take this heart out, then we're gonna roll it again. Now that has changed, right? Because this heart, there's one less heart, so then it will change. So that's what we're gonna do next here. Okay, so example 3 is important. That's what basically I wanted to cover, make sure it's covered. And I'm going to zoom out once and just ask you to do this, okay? All of these here are called independent events. What did you say? Oh, okay. I know where that comes from. Like grade 9 and 10, you do in the X and Y axis, right? But it's independent events. Like the first event doesn't affect the second, right? First event or first act does not affect the second. Sorry for writing sideways. I hope that's okay. I'm going to do this here. So independent events, the first event does not affect the second. There's nothing that the first event does that will affect the second event. Okay? So just because you roll, a sum of 7 10 times in a row doesn't mean that you should go buy a lottery ticket and you'll win, right? We always say that. It's like, hey, it's your lucky day, go buy a lottery ticket, right? That's just a saying, right? Some of you will disagree with me. It's like, no, I'm superstitious, right? I know there's something going on. But that's the fact, right? Independent events, that's what it is. And so next here, so that's first event does not affect the second. And then here, we'll put dependent events. Dependent events. First event affects the second. And this is the key word. No replacement. That is the key word right there, ladies and gentlemen. That's better, eh? If you notice that something is being taken out, especially with cards, marbles, anything, if you notice something is being taken out and not put back in the game for the second draw, well, wait a minute, something is being affected, right? So you got to be very careful. Everybody at home, listen carefully because these questions are important. It's different than what we've done so far. You have to watch out extra carefully, okay? Can I twist it back? There we go. Okay, so pay attention. Louise is playing a card game. She draws one card from a standard deck of playing cards. Then, without replacing, there's that word, draws a second card. So draws one card and then a second card. So this is first event. And this is second event. Okay. So there's a first event. I'm going to zoom back in, okay? There. So you draw a card, that's the first event, and then there's a second event. You can apply this to anything, right? If you notice that it's without replacement, right? That is like highlighted and circled, right? What's the probability that the first card drawn is an ace? So we're going to answer that here. Probability of ace How many aces are there? 4, right? Done, right? 4 of 52. B, if the first card chosen was an ace, the first card was an ace, what's the probability that the second card will be a 2? What? What's happening here? So probability of drawing a 2. Question, how many cards are left if you grab one from the deck and don't put it back? 51, right? You heard that back home? There are 51 left. So we have to effectively take away one card. This is the ace. Because you drew an ace, it really doesn't matter what the card is. If you draw and don't put it back, you're down to 51, right? That part you should understand. Okay. However, the top, how many 2s are there? Technically, there are still 4 left, right? Because the ace, if it had said, what's the probability of drawing an ace again? There would only be 3 aces left. So both top and bottom are affected. But right now, there are four 2s left, right? 4 2s in a deck. Okay? And then this is the -1. Okay? So there it is. That's dependent right there. So we're going to do a couple different scenarios. And that's where we're going to go to 159. And this I'm going to use next time. Okay, this blank page here on 159. So don't write on it. I won't do it today. I want you to work on these questions here. Work on question 7 to 8. It's basically just these two, and then it keeps going next page. So for now, for today, that's all I'm going to ask you to do. Okay. Before you start working, can you just listen one more time, look up to the screen. So this is today. Okay. Tomorrow, we're going to do this. Okay. We'll just do Wednesday. We'll write down Wednesday. Because otherwise on the video it'll be like tomorrow, right? Wednesday, April 28th. We'll work on this. Okay. So this is on page 160. The reason why I'm saying that is I might not be here for this class. So if I'm not, you know where to go, right? But there's a slight chance that I won't be here. I have an appointment. So. But this is today, right now. So go for it.